to present this year's Science and Society annual lecture. This lecture is organized by the Institute of Science and Society and supported by the College of Liberal Arts and Sciences, and the government of the student body, the University Lectures Committee, and Miller Lecture Fund. Before I introduce Dr. Bierbaum's bio to you, our president, Geoffrey, wishes to welcome Dr. Bierbaum to ISU campus.
Thanks very much, Professor Lee. Good evening, everyone, and welcome to tonight's lecture, Science and Society, to be given by Dr. Bierbaum, who is Dean of the School of Natural Resources and the Environment at the University of Michigan. This lecture series is held once a year, is sponsored by Iowa State University's Institute on Science and Society, led by Dr. Lee. The Institute brings together about 90 faculty members from all across the university, 26 different departments, to work on and study various issues related to science and technology and their impact on and interface with society. I really want to thank Dr. Lee for his many years of dedicated service to Iowa State University, for leading the Institute. Dr. Lee is in his last semester at Iowa State and will shortly take a well-deserved retirement. I want to thank Dr. Bierbaum for being our speaker this evening, and also for visiting with the President's Leadership class earlier tonight, and to thank all of you for joining us tonight, and especially for your interest in this very important topic. Thank you, Dr. Lee.
I really like to say that Dr. Bierbaum, Rosina Bierbaum, is a true icon of science in practice. Dr. Bierbaum currently is a dean of the School of Environment and Natural Resources. As a dean, she teaches several undergraduate and also the graduate classes. She does guest lecture and also deliver presentations in the international and national forums, roughly 50 a year. So I know what you're thinking of. She never sleeps. Prior to joining the University of Michigan, she served in the White House under the Clinton administration as the Senate-confirmed Associate Director for Environmental Research, which is about $5 billion enterprise. She also served the administration as acting director of the Science Policy, Office of Science and Technology Policy for the President. Prior to joining the White House, Dr. Bierbaum also served the U.S. Congress in the Office of Science and Technology Assessment. She served over a decade, first as a congressional fellow and then later as a science policy expert on ocean research and environmental science. Dr. Bierbaum's career as a scientist in practice is marked by numerous headlines. One such headline was Dr. Bierbaum led the U.S. delegates to the Intergovernmental Panel on Climate Change, the so-called global climate change, that panel, in 1988 in Costa Rica, and 1999 in Montreal conference, finally Shanghai in 2001. So currently, Dr. Bierbaum also serves as a trustee or board member in some 19 boards that are all related to energy and environment. Without going further, let me have the honor to introduce this remarkable icon of science and practice, Dr. Bierbaum.
Thank you very much. I've never been called an icon before. I really like that. If we could unsheath my first slide. I hope tonight you're going to notice that I've worked a little cardinal into my normally maize and blue slides on your behalf, and I've had just an absolutely wonderful day here. I did not ever aspire to be the President's Science Advisor, but over the course of my career, I did become increasingly concerned about the public perception of science and the science policy interface, and felt that working at that intersection was actually as noble an enterprise as my original career plan, which was to be a marine biologist in a beautiful saltwater setting, blissfully ignorant in my lab of anything political. I do believe it can be a noble calling, and I do think, though, that we all, as citizen scientists, have a role to play to fix the relationship between science and policy, which I think is currently broken today. First, I want to make a few assertions about environmental science and policy. The public does care about science and environment. Poll after poll after poll shows this. Clearly, good policy requires good science. I think that goes without saying. Environmental science is broad, complex, and poorly understood by most people. And as we see the interconnectedness of environmental issues, this is becoming even more true. But environmental policy is also broad, complex, and poorly understood by most people. And that makes for a very difficult learning curve, those 2 points. And finally, and I think most insidious, is that there is a campaign of misinformation about both environmental science and policy. Let me make a few assertions about the White House and the federal agencies. This should go without saying, but the White House obviously focuses on the president's agenda. The federal agencies focus on law and their missions, but of course they are led by political appointees, and so that reflects the president's agenda. Congress makes the laws, but we've been watching recently, and it's often with great difficulty. Many of our laws, our environmental laws, are outdated, are in some cases ambiguous, or poor, and we see lots of court battles. There's special interests on all sides, and stalemate is a not uncommon outcome. And so really there's kind of a cacophony of voices, and maybe that's obvious to you, but I just think sometimes a picture is worth 1,000 words. And so let's just look at this system. So the federal agencies shown down here as NASA, the Environmental Protection Agency, NSF, Department of Energy, Commerce, they really have two masters. So they have the president, who puts out the president's budget, as he just did, and that's put together by the Office of Management and Budget and the Science Office in the case of the science budget. But then the Congress is ultimately going to turn this potential thing into a true budget. Oops. However, there's lots of advice going on in all places. So the president has a President's Committee of Advisors in Science and Technology. The Congress has hearings and expert testimony. The National Academy of Sciences advises everybody, and each of the agencies has their own expert advisory committees. Oops. But there's also lots of pressure. And as you look, there are special interests in media involved in all, consumers, advisory panels, and so the cacophony grows, and sometimes agencies actually just erect barricades to protect and defend. So things may or may not happen, they may just hunker down. So this is the milieu within which I worked for 20 years. And let me just very briefly tell you some lessons I learned from these 22 years. They may seem simple and trite here, but I hope that as I go through them, they'll seem more important. Science is not the loudest voice. Timing is all. Small is beautiful. An unsustainable trend is unsustainable. All missing science can't be done at once. And science must be policy relevant, not policy prescriptive. The first one, that science is not the loudest voice, I think is very important. Scientists can't expect anymore that science R&D is simply an entitlement. The dollars that go into research budgets compete very appropriately with veterans' benefits, with school lunches, and so a scientist has to explain why the work they do is of value to society, and that would be one of the first things I would say is if you cannot explain why the work that you do is important to your spouse or to your mother or to your aunt, then you are not truly a civic scientist. Second, a scientist cannot constantly yell, "The sky is falling," and it's important to place the body of scientific information into the appropriate context when talking about it to any particular person. One anecdote, every Wednesday and Thursday night I would be in complete panic because the magazines of Science and Nature would go up on the web for everyone to read. And the next day, the newspapers would report something about the issue of Science or Nature, and I would have to guess what little factoid would be plucked out and dropped into a press article, and how it would be played, and how I should get the appropriate information over to the West Wing in case it came up in the press briefing. And so if you think about any particular issue, say, how much carbon do terrestrial ecosystems hold? Every week there'll be a story. One week the temperate forests are taking up more carbon than North America is emitting. The next week, 9% increase in photosynthesis. The next week, El Niños release carbon. And this kind of cacophony as the envelope of science is being expanded, but this noise around the chaotic boundary there gets torqued in the press as saying, oh, the science of climate change is wrong, or we don't know what's being stored or what's being released in terrestrial ecosystems. And so the role of the scientist is, I think, really to take this noisy, chaotic boundary of science and place the new facts within the body of information that exists. The very first week that I was in Congress, so this is use it wisely is the answer. Use your voice wisely and appropriately. So the first week that I was in working for Congress, my boss asked me to put together a flow chart, which I can't seem to get back to. There we go. Of how we should study what was then the nascent issue of acid rain. And I said to some students earlier today, in fact, one of the members of the congressional committees thought acid rain was a rock group. This was really early in the 80s. Nobody knew it. And so I put together this flow chart, and I said, well, I'm a scientist. Here's what you should do. Science is truth. We'll start with what we know about the sources of pollution, the atmospheric transformations, the mediating factors, what it does to natural resources. And out of that will flow societal concerns. And then the policy will be obvious. It'll flow from the science. And my boss burst into laughter at my grand synthesis. And he didn't fire me, but he said, no, you're completely wrong. And this is really what the decision-making process looks like. Much more like a series of Chinese boxes. Big overarching decisions are made about public policy issue, and these are set. Societal concerns feed into these. And science down here, the smallest box now, is brought into play as appropriate. And early on, I learned that this is not incorrect. If you think about the early years of acid rain, the big science questions, which pollutants to control, by how much, and over how big a region, were all answered in the early 1980s. The question, how to balance the societal concerns of the high sulfur coal miners and the cost of scrubbers, took a decade to resolve. The policymakers were completely comfortable dealing with uncertainty and answered the questions that the scientists thought were the difficult ones early on. Now, science is not the loudest voice, but the composite body of science can be, and the steady drumbeat of science can make a difference. And here I show you in 3 different statements the concluding summaries of the Intergovernmental Panel on Climate Change, the climate science consensus body of 2,000 scientists, 150 countries, and this product is put together every 5 years. So back in 1990, this was their grand synthesis. The observed increase could be due to natural variability, or that variability in man-made factors could have offset a man-made greenhouse warming. Kind of unclear what they're saying. By 95, when they revisited it, they said the balance of evidence suggests a discernible human influence on global climate. So they're saying there's a human signature. By 2001, look what they're saying. This is a group of scientists. There is new and stronger evidence that most of the warming observed over the last 50 years is due to human activities. An amazingly powerful statement to come out of 2,000 scientists. And in one of those cosmic confluences of time, as Dr. Lee said, I was leading the science delegation where we gavelled this sentence down at 1 a.m. Shanghai time, which was also 12 noon inauguration day back here, or back in D.C. And I thought, my goodness, we are taking home to President Bush this new and powerful statement that climate change is real and needs to be acted on. And of course, it was only very shortly thereafter that he walked from the Kyoto Treaty. Well, how is it that the scientists, the steady drumbeat of science, could say this? There were several new lines of evidence that only became apparent in 2001. One is we had a long enough record, of course, to show that the temperature of the Earth had increased over a degree since 1860 when we started taking measurements. But we had this new 1,000-year record, here's the year 1000, of the planetary temperature. Big error bars, of course. But on that 1,000-year record, here's the same 160-year record in red, and you can see how anomalous it looks, even with the big error bars of the last 1,000 years. And so this reconstruction of a 1,000-year record gave the scientists confidence that things were really unusual. The second thing was that the climate models, which have been used to project how climate will change in the future, were run backwards. If you have everything that you think needs to be in the climate models, and you've got most of the factors accounted for, you should be able to run it backwards and reconstruct the actual temperature of the planet. Here, the red line in all three is exactly the same. That's the temperature record of the planet. Now, if you run the models backward and you only put in natural variability, that is sun, El Niños, volcanic eruptions, emissions of local air pollutants, you get the gray band. Not very good match. If you put in only man-made emissions, greenhouse gases, etc., you get a very good match in the last 50 years, not so good in the middle. If you put in everything you know about natural and everything you know about anthropogenic, you get a very good match for the record over the last 150 years. And this increased confidence in the models is another thing that gave the scientists the comfort to say most of the warming in the last 50 years is due to human influence. So science can be a steady drumbeat and can be a powerful voice over time. Each of the IPCC reports actually did lead to something happening in the negotiation session. So the 1990 report led to the 1992 Rio Conference, which called for a stabilization of the atmosphere at levels that prevented, quote, dangerous anthropogenic interference with the climate system. So the world agreed something should happen. By the 1995 report led into the 1997 Kyoto Treaty, which called for reductions from the rich countries. And then the 2001 report was intended to lead to next steps. And of course, that's when the U.S. left, that kind of threw the rest of the world into turmoil. The second lesson is that timing is all, and that bad timing can be lethal. And here I show you the cover. Maybe not. So I just need to get the angle of this right. Oops. Well, we went right by the cover. The infamous National Assessment of the Impacts of Climate Change in the U.S. This report was mandated by the Congress, and it was completed between 1997 and 2000. We did 22 regional studies. Several sectoral reports involved hundreds and hundreds of stakeholders and scientists, 3 levels of review, impeccably done. I handed it to President Clinton in October of 2000, the heat of the election season. There was no way, after all these years and all this hard work, that this thing could be anything but a political football. And to add insult to injury, a lawsuit was initiated by the Competitive Enterprise Institute, questioning whether some of the meetings had actually been held in an open fashion. So a swirl of controversy developed around it. It came out in a political season, sank like a stone. And I would say timing killed this incredible project, which is coming back a little bit. The Union of Concerned Scientists is producing sort of regional studies that are reusing some of this information and updating it. Another example of timing is, of course, the whole negotiating timeline. And so when the U.S. pulled back from Kyoto, we had been working on it since 1988. That was when the Science IPCC was established. In 1992, the Framework Convention had been developed, the Kyoto Protocol, 97. And then from 2001 to now, it's not clear what's happening. And so in 2001, when the U.S. Abandoned Kyoto, our State Department folks said that they could not go to any meeting on any topic, human rights, biodiversity, refugees, whatever, without climate change coming up. The rest of the world was so mad at us that it was really this kind of steady drumbeat. However, as you know, when 9/11 happened, the world joined forces, and that took climate change off the table and the concern about the U.S. not being a good citizen in climate change. So timing can put climate change on the table when the science seems right, and the timing 9/11 took the whole issue off the table, and you see a bit of it coming back, but not nearly the way it was in 2001. My third lesson is small is beautiful, or the acronym KISS, keep it simple, stupid. And time again, I would go into the Congress and talk about climate change and what it might mean. And I would say, a third of the tree species are likely to change type as we go through a doubled CO2 world, and their eyes would glaze over. And I'd say, no, to an ecologist, this is really a terrible thing. And so finally, the ecologists developed this picture. And this says, all these colored areas of the globe are going to change ecosystem type. And, you know, some of them are actually going to get better and be more productive, and some of them are going to degrade, and some of them are actually going to go extinct. And this kind of graphic, which was still true enough that the ecologists could believe it, but without all the details, was enough to give a visual representation to the Congress and help them understand what climate change means. And I remember in one case, I was having such a hard time that I actually developed this next graphic, which is the Baltimore Oriole distribution. And as you know, the Baltimore Orioles were also the closest team to Washington, D.C. And I said, but listen, you know, the upper one shows you the distribution of Baltimore Orioles today. The lower one shows you their distribution tomorrow. It's going to become the Buffalo Oriole. And and also they would be gone, I would point out, from Iowa too. And again, you know, something that just sort of displays the world is a different place than you understand it to be, often prove far more helpful than sort of mountains of scientific details. The next lesson is an unsustainable trend is unsustainable, and act to change it. And you know, this should be self-evident, but I think sometimes we can get so buried in an issue, in the details, that we just kind of forget the forest for the trees. And I think you just have to be careful sometimes to step back and not let the pursuit of the perfect stymie you from beginning to act. If you don't change direction on the CO2 curve or the species extinction curve or the human population curve or the nitrogen deposition curve, you're going to end up where you're headed. And obviously, that's not what you want to do. To turn a super tanker around, you have to start. A journey of 1,000 steps starts with the first step. None of these trends can go on forever. And I think we have to remember at some point you don't need to dot every I and cross every T before you know that there is a time to start to change the direction. The next lesson, all missing science can't be done at once. Congress would get so upset. For example, in the Global Change Program, it grew from $100 million to $1.7 billion. And every year, the scientists would go in and say, we thought of new things we want to do. We want to do this. We want to expand this. We want to grow this budget. And Congress goes, but you never stop. Don't you ever know enough about something to just stop, and then we can move on and study something else? And so their idea of trying to get their arms around it was to do assessments. And that is to require that we stop at some point in time every few years, whether it be for the U.S. or in this case the international body, the Intergovernmental Panel on Climate Change, and put together what the science says. What does it tell us about what's known and what's not known? What does it tell us about what's most important to know over the next few years and what's knowable over the next few years? And help us define a short-term and long-term research program to get to those answers. And so the Congress required an assessment on the U.S. of impacts of climate change, and the international community does these assessments every few years. It's not the kind of work scientists are normally trained to do, and unfortunately it's not the kind of work that our university systems are very comfortable rewarding with promotion and tenure. And yet I would argue this kind of synthesis work is very important in terms of helping society move forward on different intractable problems. Out of some of these assessments have come some very important research needs. One, that we better get a better handle on understanding multiple stresses on systems, that climate change is but one of a number of things, whether it be habitat degradation or biodiversity loss or pollution, all happening simultaneously to our social, our ecological, and our economic systems. And fixing one could potentially exacerbate or create another or be ineffective. The second area, coping with extreme events and their consequences, climate change, as it changes the hydrological cycle, speeds it up, increases evaporation, increases droughts, but also creates more water that comes down as rain and also increases floods, will cause both more droughts and more floods. And we don't deal with extreme events very well now, and we expect them to increase in the future, so we better get a better handle on them. And the third is the trend of emissions is unsustainable, and we better get on with the rapid development of clean technologies. And let me show you a slide on each of these. First, on the multiple stresses. Clearly, climate change interacts with other issues. I mentioned terrestrial ecosystems. Carbon dioxide, the chief greenhouse gas, is a plant fertilizer, so it might lead to forests growing faster for a while. But drought might lead to forest fires and the loss of carbon, and whatever's growing faster may or may not interfere with what you're trying to preserve in terms of biodiversity. Or think of the air quality. Climate change, a warmer climate, will exacerbate or enhance the formation of smog. And here, let's just look at two panels. This is the 1990 climate with 1990 emissions, and the red smears, the unhealthy levels of ozone, are only in a few places. But we project that by 2050, with the emissions of 2050 and the temperatures of 2050, that we will have a huge smog problem in much of the Northeast, and it's even beginning to spread over here. That suggests that our typical approaches to control air quality for human health will not be sufficient as we're thinking about climate change occurring simultaneously. So this is an important example of how we need to think about these multiple stresses together. And I don't know why I'm having this trouble. The extreme events, this shows you the number of billion-dollar disasters over a number of years, and you can see that they're increasing. And as I said, we expect droughts and floods to increase. There's some possibility that hurricane intensity will increase. A lot of this is due to people living in the wrong places, but if we expect that disasters are going to increase and the dollars related to disasters are going to increase, we better learn how to cope with them better today as well as tomorrow. And for one that's near to home, this shows you corn yields starting at about 40 bushels per acre, climbing up to about 135 by about 2000. Very clear increase in productivity over time. But look that even in a country like the U.S., we can lose up to some 30% of a corn yield due to extreme events of blights and droughts. So learning to cope with them better is insurance for today as well as for tomorrow. In the area of energy, how big is the task? And this chart, I'll try to make not confusing at all for you. First of all, here we are. We emit 7 billion tons of carbon per year into the atmosphere from burning carbon fuels. This orange line is our business as usual line. We'll be screaming towards 20. billion tons. That's business as usual. If you wanted to stabilize concentrations in the atmosphere, you'd have to be on one of these curves. Note, if you want it to stabilize at 350, you have to go below zero. That's because emissions or concentrations are already at 370. That's a future that's precluded to us. Say you wanted to stop at twice pre-industrial levels. Atmospheric concentrations are 30% above. We'll go through a doubling in several decades. But say you want to stop there. Couple of things to notice. The line has to peak at 10 billion tons. Be about 10 billion people in the world, 10 billion tons, a ton a person. We're at 5 tons. Each of you is responsible for 5 tons. The average developing country person is at 1/20th of that, or 0.4 tons. And whether or not you think the whole world can veer off this business as usual orange line and head downward in the next 25 years is whether you're an optimist or a pessimist. Let's see what it would take to do that. You'd have to basically lop off a triangle of this kind. Well, here's one analysis, again, that looks busy, but I'll try to make simple. It says you want to lop off a triangle of carbon emissions, you need to come up with 7 wedges of 175 billion tons of carbon each. This chart says here's 15 possible ways. And one I would like to show you right from the beginning, we did in our energy budgets this year increase the nuclear budget by 37%. If we could triple nuclear power in the world today, triple it from what we have, we could get one of those 7 wedges. And so that's kind of a daunting task. But then on the more optimistic side, 4 of the 15 wedges that they show have to do with renewables here. And you see biomass fuels and wind and photovoltaics. And that's kind of a perhaps more doable thing. Remember, we need 7, so there's 4. And another 4 of their wedges have to do with efficiency. In the budget, the president increased renewables by 40%, principally photovoltaics and biomass. Very good news. Dropped efficiency budget 16%. Very bad news. But nonetheless, the 7, perhaps, from these 8 could, in fact, be gotten. The last, so assessments in these previous messages of we need to think about multiple stresses, we need to think about extreme events, and we need to deal with energy. Assessments can help make some sense out of all of the issues related to what might happen to all of the sectors with all of the impacts of climate change. And so assessments can sometimes distill the most important things to move on. The 6th lesson, science must be policy relevant, not policy prescriptive. Avoid politicization and defend the truth. And this is where I think things have changed in recent years. So I put them in large cardinal and black colors here. We can all have our own opinions, but we can't all have our own facts. It appears that there's almost this sort of this Disney just wishing makes it so rule of science facts out and about right now. So let me just go through some of the facts briefly. I showed you the 1,000-year record of temperature once before. Here it is again. Here's the anomalous last century. Here's the temperatures that the Earth will go through under 40 different scenario estimates. So this is the full range of estimates of what the temperatures will go through during the lifetimes of the children of the students in this room. Clearly outside the norm. I think this is undoubtedly unsustainable trend. We are seeing multiple effects worldwide. Glaciers are melting everywhere. We're seeing fall come a week later, spring come a week earlier, shifts in plants and animal species. The West is losing snow 2 weeks early. And in fact, here's just a map of places all over the globe where various impacts have been studied. This work was all part of the original IPCC in 2001. Now, since 2001, evidence is growing, more worrisome. Rapid ice melt in both Greenland and the Arctic, deadly heat waves as occurred in Europe, increased intensity of major storms, including hurricanes, increased frequency and intensity of droughts, increased frequency of floods, and increased species range and behavior moves. And let me just talk about each of these a little briefly. Oh, and increased frequency and extent of wildfires. So I think you've all seen this incredible graphic of the shrinking polar ice cap. This ice is floating, so it's not adding to sea level rise, but as it melts, it will absorb more heat, the darker water, and there will be a positive feedback. We're talking about an ice-free Arctic in the next 60 years or so, and that will be a very different place. This is Greenland in 92 and 2002, and most of you know that 3 weeks ago at the AAAS meeting in St. Louis, they announced that in the last 5 years, Greenland's rate of ice melt had doubled, and our climate models don't even know how to deal with that kind of rate of change. We assume over hundreds of years that the ice sheets are going to be destabilized and melt. So this is actually a very scary one. And the projection is that we might need to think about increasing the sea level rise that we've been talking about of a half a meter, that it may be a big underestimate. If all the ice in Greenland melts, that would be 7 meters. If the ice in the West Antarctic ice sheet, that's what WAIS is, that's another 5 meters. And there's some sign of destabilization of that as well. And you know something's made it when it makes it into a cartoon. This is the Greenland ice sheet, and it says, "This is the most dramatic Winter Olympics closing ceremony ever." And it says, didn't get the ratings either. Heat waves. This is 35,000 dead from the heat wave in Europe in 2003. I would note wealthy part of the world for the most part. The weather patterns that occurred during this heat wave, according to several climate models, are projected to occur once or twice a decade as we move to the end of this century. So heat waves, worrisome. This is Katrina, of course, and you know there have been a number of articles that have talked about, at least in the last 30 years, the number of 3, 4, and 5 hurricanes in world basins have increased. We know the temperature in the Gulf has increased. We know warmer water leads to more energy. So once hurricanes form, there's every reason to believe that if it's over warmer water, they can be more intense and they can produce more rainfall. Number of floods by continent and decade since 1950, pretty self-explanatory, increase every decade except for Oceania in the number of flood events, and the number of wildfires by continent. These are both from the Millennium Ecosystem Assessment. Not to say that these are all caused by climate change now, but they are increasing in frequency, and we expect that climate change will also increase them. And species, again, another cartoon. This says, puzzle time. All 4 walls of your house face south. You look out a window and see a bear. What color is the bear? The answer is there is no bear. All the polar bears went extinct from global warming, and your house fell through the melting ice and you died. And then it says, and your son too, SUV too. This is Tolles, who has his cartoons in the Washington Post. But in terms of species shifts, which is what this is supposed to be about, there actually have been some 279 species studied. 84% of those are moving either northward or up, northward latitudinally or upward altitudinally in response to a changing temperature. And finally, last commentary on we can't all have our own facts. When the president said that we were not going to meet Kyoto, which would have required us to reduce our emissions from 1990 levels 7%, he said instead we were going to achieve a 14% improvement in our energy intensity, which is pollution per dollar of GDP. So that's a ratio. As long as the denominator climbs faster than the numerator, you get there. And so what he promised was that we would be on this line. This is our historic intensity improvement, and this is what he promised. But a lot of Americans, I guess proving that we'd rather commit suicide than learn arithmetic, which I think George Bernard Shaw said 14%, that's more than Kyoto, which was only 7%, so we're doing well. But of course, an improvement in this ratio does not mean total emissions are not increasing. And so in fact, what we promised is that this is what our future would look like. We would end up increasing 25% instead of reducing 7%. So I think this is really a wake-up call to us, citizen scientists. I mean, a number of things that I think are quite phenomenal happened. The president was able to reject Kyoto, 13-year effort with 150 countries of the world without the U.S. having a real public outcry. And despite what I said was a real drumbeat of international criticism until 9/11, the White House was able to encourage and manipulate the Department of State and EPA reports to take out or mislead in terms of climate sections. And I'm sure several of you have seen what the whistleblower had in terms of records from Phil Cooney's edits of a climate document. Members of Congress get away with outrageous statements about the science of climate change. Senator Inhofe from Oklahoma calls it the greatest hoax perpetrated on the public. And many of you have read Michael Crichton, and he's convinced that the science of global warming is a hoax. And the president asked to be briefed by him on climate science. I said to one of you recently in the car that a climatologist said to me, Michael Crichton's a heart surgeon. When he lets me operate on his heart, I'll let him tell me about my climate science. I mean, it is, who's an expert anymore? And why is this happening? One that's very close to me because it's very personal. In 2001, I stayed for the transition in the White House and served as the acting director for the science office until the president's science advisor was confirmed on Halloween of 2001. ExxonMobil sent in on 8th of February 2001 to the White House Council on Environmental Quality that they should get rid of White House holdovers, there I am, because they had recommendations about a team that can better represent their interests until key appointments, and that the U.S. was being represented by holdovers with aggressive agendas. So that's a very personal one. So a few science policy matters of concern along with this politicization and related to this politicization. First, money to fund science, the public understanding of science, respect for science, and policy informed by science. So let's start with money. Here's the 2007 budget of the president. There's good news and bad news here. NSF finally is going to increase. That's good news. NASA's increasing, but it's all space. It's space vehicles. It's not space science. Geological Survey deals with a lot of water issues. Department of Interior. NOAA, Oceanic and Fisheries. Environmental Protection Agency, Department of Agriculture, the science part of Department of Defense, Department of Transportation, all significantly down. This is the third year that the research budgets will be dropping to, and this will be to $54.7 billion for discretionary R&D that's non-defense. And so it's very worrisome that so many of those budgets that relate to the environment are decreasing. We are, of course, pleased though that NSF might go up. Well, okay, public understanding of science. Well, there's good news and bad news. Here's the good news. More than 70% of the population actually understands that plants produce oxygen, that continents have been moving, that light is faster than sound, that the Earth goes around the sun, and that not all radioactivity is being. Only 50% understand that humans weren't there with the dinosaur, that it actually takes a whole year for the Earth to go around the sun, etc. So these are not too good. However, on the bad news side, look at more than 50 people believe in psychic healing, ESP, haunted houses, ghosts, ET, astrology, and look at evolution. Teach only evolution. Only 20% of the American population do not teach evolution at all, 16%. I just came back from, again, the American Association for the Advancement of Science meeting. National Science Teachers Association had a meeting. 30% of the high school teachers said they were scared to teach evolution exactly the way it was because of all sorts of criticism coming from parents who say, my kids don't have to get sex education, they don't have to get evolution. And that there was really a fear among the teachers about teaching science. Okay, respect for the integrity of science. Well, something's changed. And in the beginning, the Union of Concerned Scientists, which has led this campaign, and I encourage you to look at the website if you want to see what the documentation is for politicization or misuse of science. What they did is they convened 30 people who had served in 6 previous administrations as science advisors or heads of agencies, and we talked about health, environment, national security, and systematically the group concluded that nothing like what's happening today had happened in the previous 5 administrations that they had been part of. Things like on the Health and Human Service website, breast cancer was linked to abortions, what's been happening with climate change, disbanding of advisory panels on nuclear proliferation, inaccuracies in stem cell, for example. And that led to a very prestigious group of 62 scientists, including a tremendous number of Nobel laureates and Medal of Science winners, and subsequently signed by some 4,000 scientists. Following that report, a group of scientists and religious leaders got together, and it was sort of major religions of the world and then representatives of major science topics, and signed this statement that global warming is a universal moral challenge and Earth's climate embraces us all, calling for action. The last one, policy informed by science. Well, we're really not doing too well in terms of developing climate policy or energy policy, but I actually think the landscape may be changing, and so I am hopeful. And the reason I'm hopeful is that I think a lot of things have happened in the last year. The Senate resolution, which was 62205, said it is the sense of the Senate that Congress should enact a comprehensive and effective national program of mandatory market-based limits and incentives on emissions of greenhouse gases that slow, stop, and reverse the growth in a way that doesn't harm the U.S. and will encourage comparable actions by other nations. A far cry from the 95 to nothing vote we got on Kyoto when we came back in 2001. That's a significant change. And then an incredible amount of pressure coming from cities, all these mayors across the country that have adopted Kyoto or more targets. We're seeing a lot of activity in the states, including here, where you have a renewable portfolio standard. Corporate America is stepping up, the international community, the science, as I said, is getting ever stronger. And the evangelical statement only a few weeks ago about climate change was an amazingly powerful statement. So if you look, this is just sort of a composite of what various industries have pledged in terms of reduction targets, and then in some cases the money that's being saved. And so clearly there is a way to reduce emissions and make money. And of course the energy price signal that we're currently getting is not hurting. In terms of states, in 2001, there were only 4 states that were doing anything. Look at this in 2006. We have 20 states who have a renewable power standard. We have 5 states that have renewable fuel standards, and we have 3 states that are doing both. And there you are, and I'm very sorry to say Michigan is not there, but we actually have a student project that's working on developing a renewable portfolio standard for the state. So I think that's a very positive statement, so to speak. And then we're beginning, as I've shown you already 2 of, to see cartoons that are criticizing what appears to be the clamping down on scientists. And so this says NASA shuttle program, and this is NASA shut up program. This is clearly referring to Jim Hansen, the climatologist, who was discouraged from talking about climate change, Greenland melting, and 2005 being the warmest year on record. And one that just appeared yesterday, I might have to read this one to you. Doonesbury, really close to my heart, because the Dr. Nathan Null is actually the president's science advisor, which was the position that I briefly held. And it says, fudge, that can't be right. Time for a new calculator. Drat, these pesky scientific facts won't line up behind my beliefs. Then challenge them, Stevie. Holy flat earther, it's White House situational science advisor, Dr. Nathan Null. That's right, Stevie, and I'm here to remind you. Situational science is about respecting both sides of a scientific argument, not just the one supported by facts. That's why I always teach the controversy, like the evolution controversy or the global warming controversy, not to mention the tobacco controversy, the mercury controversy, the pesticide controversy, the coal slurry controversy, the dioxin controversy, the Everglades controversy, and the acid rain controversy. You're right, situational science man. I'll never trust science again. It's just too controversial. Stevie gets it now, folks. Do you? So, as I say, that one was particularly upsetting to me. So, I think it's time for a new approach. We've got to improve the science, and as I said, especially understanding extreme events and understanding multiple stresses, particularly as they'll affect each of us in our region. Climate is changing. We've got to get on with developing adaptation and coping options. We've got to devote time to policy and education as civic scientists. There's a role for every one of us in this room. We've got to separate the science and the policy from the politics. We've got to recognize the realities of energy and economic needs, but we do have to invest, and I mean seriously invest, not just $2 billion in an $8 trillion industry in the world, but seriously invest in clean energy now. We've got to criticize exaggeration on both sides. We've got to form alliances with other fields to defend science. We've got to build bridges between university, federal, and industry labs. And we've got to lobby hard for research funding for all fields, not just for the fields in which we are, because, in fact, of course, science is the underpinning of the future of society, and physics and chemistry and biology and environmental science are all equally important, basic and applied, to move us forward. And I just wanted to end with Albert Einstein's quote, "Everything that is really great and inspiring is created by the individual who can labor in freedom." And that's what we have to hope for our science enterprise, because we're leaving you this planet, students, and I hope that we can leave it to you in a sustainable way for your children. So thank you very much.
Questions? Dr. Rosina will take some questions. So those of you who have questions, please come to the microphone. And afterward, we do have a fresh refreshment, so please join the refreshment afterward.
One of the biggest steps backward in recent years was the abolishment of the Office of Technology Assessment. Could you give us some words on whether there's any hope for bringing it or something similar back to what it did play?
Yes, and as you heard, I worked there for 13 years, so I'm not unbiased on the topic. Rush Holt, one of the two physicists in Congress, has tried several years in a row now to bring it back. It still exists on the books. It was defunded, so it doesn't take an act of Congress to bring it back. It just takes money. I think Sherry Boehlert has said he thinks he doesn't think it will ever come back. If it comes back, I think it will come back as a modest amount of funding, perhaps within the CRS, the Congressional Research Service, something like that. It's very clear Congress still needs scientific advice. There still are, only a handful of the 535 members who have advanced science or technology degrees. But this is about the third year that they've tried it. It doesn't look like there's enough energy to kind of push it over the edge. I certainly hope it comes back. I think not this year, maybe not next year. And if it does come back, it would come back initially in a small way. So I wish I could be more optimistic about it, but it looks like the political chits required to make it happen will probably not be used up by enough people to make it happen right now.
My recollection of the thermometry goes back to Galileo, which is credited for having invented the first crude thermometer. Some of the charts you were showing, they were temperature recordings of as far back as 1,000 years before. I was wondering, when a scientist does something, they have a way of arriving at it scientifically. How did they measure the temperature of something before the invention of the thermometer?
And
the second question I have, sun has a cycle that the output of energy varies over a period of time. Have those variations been taken into account when those graphs were made?
Both good questions. So there are other people in the room who can answer both of these better than I can, but let me start, and if any of the atmospheric types want to jump in, please do. The measurements before about 120 years ago, when surface temperatures were made, were determined using proxies, and there's a number of ways that you can do proxy temperatures. One way is you can take ice cores and you can measure the concentration of CO2 in the core, and you can also look at isotopic ratios and determine temperatures from that. You can look at pollen grains, you can look at tree rings, and so there's a number of lines of evidence, and that's why as you go back in time, the error bars are enormous. And the reconstruction of that graph, which is sometimes called the hockey stick, underwent some serious scrutiny a few months ago. But I think for the most part, the shape has been relatively corroborated. There's some noise around 500 years ago that there's some dispute about, and the inter-century change in temperature is disputed. So there are a variety of means by which you can determine longer ago temperatures, and they are increasingly uncertain. But the error bars that were shown there were exceeded by the top temperatures of the last 150 years. What was the second question? Cycles of the sun. So yes, so the solar cycles, these sort of 11 to 22-year cycles. Yes, the solar influence is expected to be, I think right now, 1/4 of a watt. Somebody can correct me if that's not right. And so when I showed you the models going backwards in time and trying to match the temperature record, one of the areas that didn't match might partly have been to the solar cycle. But the solar cycle, they know the solar cycle, and that is built into the anthropogenic and the natural forcing. And it does help bring in line the temperature record better, the observed temperature record when you have it. But I guess basically the sun can't be the answer for more than about 1/4 of the impact that we're seeing today. And as we go into the future with the great increase in greenhouse gases, the percent of the solar influence will be even smaller. So they do take that into account, and I urge you to talk to the atmospheric types here for more information on that.
Hi, thanks for coming. I wanted to ask kind of a general question, but not also restrictive to environmental policy, but also in government in general, with the role of specific political agendas and special interest groups. I just want to ask you from an insider's perspective, how loud is their voice compared to the voice of science? And maybe from a comparative aspect, how does that play a role in different administrations, as in like the Clinton administration as compared to the Bush administration? So
one thing that I noticed all through my political career is that the special interest groups were really good at producing short, clear, communicative two-pagers on the topic they cared about. The science community doesn't do that, very well. And so for every clear scientific package that showed up in a member's office, for example, there would be, 20 lobbyists with a particular angle on a topic. Here's the summary of the science issue. So first of all, I would say the special interest groups are very effective at keeping it short and simple and easy to understand. And if you think of the average congressional staffer having 14 topics that's under their belt that they have to deal with, if you had a two-pager on an issue that you got a question about, you might just use that. So the first is that, the science community isn't very good at doing that. And I think the influence that special interests have probably, varies from congressional member to congressional member and from administration to administration. I mean, we certainly see a lot of indications that the oil industry has had a lot of access to this White House, and that wasn't so clear in the last White House. And what was the other half of your question, though? It was not just special interest groups, but the role of science, was that?
Yeah, part of it was kind of a comparative of, how much does science really have a voice as compared to special interests? How much do politicians listen to each?
So I was talking to some students earlier, and I was saying that, we, in the Clinton administration, you always had science at any regulatory or decision-making discussion where the decision hadn't been made yet. So if you're talking about which the mercury regulation be, or arsenic, or the ozone standard, the 8-hour standard, or whatever, you would hear, here's the box science puts you in, and then the economists would argue to put you at the cheapest end of the box, and the health guys would argue to put you at the safest part of the box. But you would be part of the discussion. I think, if anything, we consulted with everybody, including the scientists, over and over and over again. We had very consultative discussions. In the case of climate change and the Bush administration, when he said we were not going to stick to Kyoto, but we were going to do something else, every office in the White House developed a proposal and sent it in. And then the inner circle decided which proposal was going to win, but actually none of us knew until it was announced in the Rose Garden. So you gave input, but it wasn't, kind of a group discussion about what does the science say, what does the economics say. So the economists put together a cap and trade program. We put together what we thought the science piece should be. So it's different styles in different administrations. But I do feel that ignoring science, as I believe did happen initially in climate change in the Bush administration, is unprecedented. So for example, we came back from the climate negotiations with this: most of the warming in the last 50 years is due to humans. The president said, I don't like this, and I don't want to deal with climate change. So he asked the National Academy of Sciences for a second opinion on these 2,000 world scientists. And so the National Academy did a 90-day report, which is, lightning. They've probably never done one so fast, that basically reinforced that the conclusions of that report were, in fact, correct, of the IPCC report. So then they couldn't really ignore the science, so they switched to an economic argument. So it's a very different feel to it. Can one group of consensus scientists be debated by the Academy? It was, hoping for a second opinion that would take away the consensus.
Kind of piggybacking off the previous question, there has been a historical trend for federal funding to flow either into academia or into the federal agencies. In the last 6 years, as you showed on your slide, the federal agencies have endured quite a hit in terms of funding. Do you see the downsizing agenda of the present administration? Do you see that impacting federal agencies to the point where they will be outsourcing their science to academia exclusively, or industry? And can you comment on how that would impact science in the U.S.? Thank you.
Wow, well, that's certainly a hard one. I mean, I think what's really going on is we're trying to balance the budget on the back of the discretionary piece of the budget, which is a tiny, tiny piece of the budget, and that's why science is suffering so badly. So, if you look at NSF success rates in environmental science, where I think I've tried to argue the issues are bigger and more compelling, the grants are being awarded, 8% of the grants are getting awards. The overall success rate at NSF is down to 21%. There are a few that are still at 30%. So fewer and fewer scientists are getting smaller and smaller pieces of a pie. And I think it is simply, we're paying for a very expensive war and a very overdrawn budget right now. And science and everything else discretionary is unfortunately trying to take the heat. I don't know what to say about outsourcing. I mean, in the areas of the federal government that I know best, the workforce in Department of Agriculture, Department of Interior, EPA, is all set to retire in about 5 to 10 years. It's a really aging workforce. So I don't know if that's going to end up with retire and don't replace, or a lot of people in this room are going to get hired and come in with new concepts about the environment. But I think it's a very significant potential brain drain that's going to occur. I think academic institutions are in terrible straits. I mean, we count on those federal research dollars to train the next generation of students. And you look at, anything from what happened with NSF's $100 million of education grants that all got shipped over to DOE so that the science community who wants to have NSF grants no longer can get them from NSF for education. Maybe they'll go to DOE. I mean, I think it's a very insidious thing. Those monies helped a lot of K through 12 and undergraduate education. The grants that support our graduate student training are drying up. And so I think the universities are in as much trouble as the federal agencies. I don't know how to answer your question about outsourcing or how we'll get the research done that we need it to, but it's clear the U.S. workforce of scientists and engineers is in deep trouble.
Hi, thanks for coming. What alternative energy sources do you think should be most aggressively pursued? And I was wondering if you could comment specifically on ethanol and whether it is a viable and effective alternative.
Well, there were a couple of studies done by one of the presidential advisory bodies, the President's Committee of Advisors in Science and Technology, that looked at what should be done to most greatly enhance domestic energy sustainability, independence, and then what we should do to leverage the potential world markets of several $100 billion over the next decade as developing countries put in place infrastructure. And the conclusion of both of these reports, the domestic and the international one, were that the greatest leverage is in enhancing research budgets for renewables and for efficiency, that there's still a great deal that we can get from both of them, that they're nearer term than fusion, which I think is always 50 years from being realized, and all of the physicists in this room probably got through school with it being a 50-year horizon for fusion. And also, they also felt that there was some underinvestment in nuclear to figure out whether the issues of proliferation and safety and waste disposal could be solved or not by the next generation. Not necessarily to build them, but to resolve that issue. And so, as I said, the sum of the energy research in this country is $2 billion, which I think is a pathetically little amount to try to, change those steeply rising trajectories. Ethanol, I think, has, and I'm not an expert on this either, I think has a real sort of at least midterm role to play. And I think it looks like cellulosic biomass is getting closer to being cost effective and realizable. And so if that could happen, being able to use things other than just corn, but being able to use switchgrass and willow and a variety of other crops potentially on wasteland or riparian areas, or being able to mow the switchgrass and regrow it, offers incredible potential. You got to get the distance that you're going to transport it right. But certainly as a transition from gasoline vehicles through hybrids with ethanol to whatever I guess we hope will be the hydrogen economy, but at least 2 decades hence. I mean, we need something to get us from here to there, and I think it can play an important role. And a number of papers have been coming out recently that are looking much more optimistic about that.
I was just wondering, you say science is not the loudest voice, and if so, then perhaps we should be the people listening to the voices. So I was kind of wondering why you chose to go from an advisor, or like be a scientist as opposed to being a politician who was listening to the voices, and what your opinion would be if we want to be making the changes, if we want to be having large effects on these things. Should we be a scientist? Should we be an advisor? Or should we just be a politician and be making the decisions?
That's a good question. I'm not sure I would be very good as a politician. I guess I meant that I think economics and policy voices have louder say than scientists do. I think it would be absolutely wonderful if there were a lot more technically trained people in charge of our country. When I worked at OTA, the House of Lords study on acid rain came over to talk to us, and so we had all of our bosses and then me, who was running the study, sitting in the room. But every one of those people who came over actually had some technical expertise, and they immediately dove into these very complicated questions. And so, the whole U.S. line of people turned and looked at, lowly me sitting at the end of the line to ask. And so it's, in other countries, we do have science and technical people running the country or in positions of power. So I think it would be wonderful to have technically trained people aspire to serve in the government. I mean, one way that's not quite so dramatic is you can do what I did for the first year, which is go and be a congressional fellow for a year. They take 50-some science and engineering graduates and have them serve in those capacities on congressional staff and on congressional committees and be a voice of science for a year. So you can do it, you can walk back and forth between academia and the government. But I really do mean when I say that I think we all have a responsibility as a civic scientist. I think we have to be literate in science and technology, and I think we have to hold our politicians accountable to deal with good science and technology. So I'm not saying what's exactly the right thing for anybody to do, but be involved in the policy process in whatever way you can, whether it's calling your members, visiting your members, writing your members, but hold them accountable for what you think is important to you and the next generation.
This will be the last question.
Okay, well, obviously some of us had our concerns with, the re-election and everything, with toxicity, but of course maybe not nearly as directly as face full of lead buckshot for potential heavy metal toxicity for people in case of this administration. But anyway, I was just wondering, to kind of build on your past comments here, what you perceive the difference to be between the American electorate and the electorate in most of the other post-industrial countries, and why is it that we as a nation are so willing to embrace an administration or policy or some combination of the two that is so non-progressive in the global environmental scientific picture?
Well, that's certainly not an easy question. I don't know that I can actually, speak generally about the electorate in other countries. I mean, I certainly know of examples where there are plenty of technical people in the equivalent of our Congress overseas. I actually feel that international lay public are better informed on science than we are here. And I think there's a composite of things going on, and I don't quite know how to sort it out, but I think one is that the American press is very driven to having two sides of an issue, not presenting a consensus and presenting things as if they're polar opposites, even if in fact there's a vast majority of scientists who agree with one thing. And so, there was the study where 900-some science articles were written on climate change, and all of them agreed humans were part of the problem and an important part of the problem. And then of several hundred newspaper articles in the U.S., 50% cast doubt on whether humans were to blame. And so there's a very real weirdness going on in the U.S. about the translation of science in the press. And so I think the press is an important piece of the problem. I think the American public is much more driven to sound bites and listening in sound bites than the international community. I mean, now that I'm in Michigan, I listen to the BBC Hour and the CBC Hour, the Canadian Broadcasting, and I would say every third night there's like a 3-minute discussion of something about climate change. I don't even hear that, on NPR. I mean, it's sort of different willingness to listen to longer stories, to more in-depth stuff, and I think it really is true that that our American public is very science illiterate and kind of doesn't care about it. I don't know what to say about this. Now you can have a scientist stand up and say this is true, and then you can have Senator Inhofe say no, it's not, or you can have Michael Crichton say no, it's not, in a field that's not theirs at all. That's what I think is the really weird and dangerous thing. Why the U.S. press gives credence to people who don't have any expertise in the area on which they're speaking, and that to me is a big change, and that does not, as far as I know, exist in other industrialized countries. I mean, I've been asked a number of times in Europe, why do these people get any press at all? They should be shunned. They're charlatans. They're not scientists. So it's this weird composite of, press and scientific illiteracy, and I can't exactly explain it to you, but I really do feel it has gotten a lot worse in the last couple decades. In the acid rain debate, or you think of cleaning up the Great Lakes, we decided we had to change the trend, and we didn't exactly know what to do, but we knew we had to make a start, and we could fine-tune it later, and we could figure out the exact roadmap later. Now things, you're not willing to deal with them in that precautionary way. It's sort of, until I have every last fact, I don't want to think there could be a problem. So it really feels like the evidence that's needed to act on a problem has changed too, from the days of could be phosphorus, could be nitrogen in the Great Lakes, let's give it a try. Could be sulfur, could be nitrogen that's causing acid rain the most, or what the endpoint should be. Let's begin to change that. So I unfortunately think it's a big change that's quite pernicious and has to be reversed.
Well, thank you, Dr. Pierbaum.
Never.
Pierbaum.
Never.
Pierbaum.
Never.
Pierbaum.